Assalamualaikum everyone. Today we are going to discuss on Chapter 8 on correlation and regression. For the first one, correlation and coefficient. For scatter diagram, graphical technique used to show the relationship between variables. Relationship between two variables differ as bivariant data. Pairs of values of x, y with appropriate scales and axes. The following diagram shows various relationships between two variables, x and y. For the first one, it shows a graph on a positive and linear x and y. Second one, negative and linear. Third one, a negative non-linear graph. And fourth, is a no relationship graph between x and y. Covariance. Covariance is a measure on how much the variables of x and y vary together. Covariance of x and y is defined as covariance xy is equal to summation of x minus mean of x times by y minus mean of y over n minus 1, which is also called as SSXY over n minus 1. SSXY can be found by subtracting summation of xy minus summation of x multiplied by summation of y over n. Let's see an example on covariance. Okay, here we have given a data on x and y, and we have to find the covariance of x and y. First of all, we have to find the summation of x and the summation of y, also the value of x multiplied by y, and find the summation of x and y. By using the formula of SSXY is equal to summation of xy minus summation of x times summation of y over n, we can get the SSXY. So here we put on the data on summation of xy, which is 124.09 minus by summation of x 16.7 times summation of y 32.6 over 5 and
0.1.3 Coefficient of linear correlation. Coefficient of linear correlation to measure the strength of linear relationship between two variables. It is also known as percent product moments and R. Covariance x prime and y prime is R, and also know convenient x y over xx xx xy. R is sx xy over square root xx xy. To search x and y, total of xy minus 2 total x times total y over total data. SSX is total x squared minus x total x squared over data, total data. SSY total y squared minus total y squared over data. The type of the graph is low negative correlation, negative 0.3, high negative correlation, negative 0.x, perfect negative relation, negative 1. This is some example for the coefficient of linear correlation. This has price per unit known as X, cell per box known as Y. It has X data, and we need to calculate percent product moment.
So next we move to regression analysis. In regression analysis, we have simple linear regression. So in a simple linear regression, we need to know the equation of the regression model. So the equation is y equal to b naught plus b1x plus error. So for y is dependent variable. B naught is y-intercept. B1 is slope or gradient. So x is dependent variable, and for error is the experimental error. So for this question, to find B1, the formula is SSXY divided by SSX, and for B naught, mean of y minus by b1 multiplied by mean of x, or we can find it by formula summation of y minus by b1 multiplied by summation of x divided by n. So this formula is for y, which is the for observed value. For estimated regression model, we use different formula. This is the formula, which is y equal to b naught plus b1x, or the formula is also similar with equation with formula y equal to x plus mx, and also y equal to mx plus c. So next we move to the example. So this is table. Okay, for B, calculate the coefficient of linear and interpret the value. So the coefficient of linear is R. The formula for R is SSSY divided by square root SSX multiply SSY. So the value of SSY we got from previous question. And for SSX, this value, and SSY, this value. So we just put it into the formula, and we got the answer is 0.9878. So the positive value of R show positive relationship exists between X and Y. Next, we move to C. Find the equation of the regression line of X and Y. So the equation is y equal to b naught plus b1x. So for b naught, we can find it by formula SSXY divided by SSX. So we got this 1.6809, and for b naught, the formula is summation of y minus b1 multiplied by summation of x divided by n. So we got this, just substitute the value, and then we got the answer 0.0067. So for the equation,
Next, we have experimental error. Experimental error include of human error, mistakes in data entry, and random error by environment condition or unpredictable factors. So in this chapter, we need experiment design to minimize experimental error and produce most accurate data. In experimental error, we need the variance. So this the formula of the variance is equal to total y minus the y, or y is the observed value and the y is estimate value. We have to square root, then divide by n minus 2, and n is the number of data. So we have to derive the equation. The derivation is equal to total y minus b naught minus b1 x square root divided by n minus 2, and then total of y square minus b naught times total of y minus b1 multiply with total of xy, then we divide by n minus 2. So this equation is the SSE. SSE is the sum of squares for error. Then we have to divide by n minus 2. So in this experiment error, we have the graph. In this graph, we can see this is the observed value and estimate value. Observed value y, we have 2, 4, 5, 4, and 5. This is the observed value. Then we need the regression line to make the estimate value. So observed value minus the estimate value, we get the error. So this is the error, and this is also error. Then we move the data to the table. We have y, the observed value 24545. This the estimate value 2.8, 3.4, 4, 4.6, and 5.2.
Then we have to minus estimate value minus the observed value. We get 0.8, negative 0.6, negative 1, 0.6 and 0.2. In the formula, we need to square root this value. So we square root it. So we get 0.64, 0.36, 1, 0.36 and 0.04. Then we substitute this value to the formula. So the variance equal to total estimate value minus observed value square root divided by n minus 2. So we get this 2.4, the total of this, and 3, that's 5 minus 2 because we have 5 data, 5 value. So the answer is 0.8. And if we want to find the standard error of the estimate, we just square root the variance. Okay, thank you.